I just earned my doctorate in chemistry at Tufts University on the Medford campus in January. So I'm going to do kind of two perspectives on data management. I'm going to go through my dissertation project and just to show you the amount of data and how sometimes it isn't so pleasant to work with. And then when I finished my PhD, I actually started a temporary position with Research Data Management Systems project at Tufts. So I switched from the lab to going to a ton of meetings and really learning about the electronic lab notebook world. And so that's going to be the second half of my project, and it ended up being one of the best jobs I've actually ever taken because it taught me quite a bit about data management and how to organize my data. So as Regina said, please feel free to interrupt, just raise your hand, and it's probably easier than waiting till the end anyway. So. Okay, so like I said, I'm going to first go through my first perspective on data management, which is my dissertation project. And just to give you kind of the overarching theme of the research, so as I'm sure you know, the uprise in demand for natural products and organic products is all because people know that there have been numerous research studies that have proven that X compound in this beverage has cured some disease. So as you can see here, I have lavender for neurological disorders. Lemon compounds have been shown to eliminate cardiovascular diseases. Mint, cinnamon, pretty much all natural products have some sort of chemical components that alleviate symptoms for diseases. And so this brings us to the tea project, and Regina is very familiar with this project. She ended up actually writing the data management plan for the NSF grant that we applied for. And so, as I said, I was from the chemistry department, but this project also involved people from the Boston campus, which were in the nutrition school, and the biology department. And then we actually had two researchers that were outside of Tufts at Montana State and University of Gainesville, Florida. So it was a very big collaboration project. As you imagine, there was data flying around everywhere. So just kind of give you a brief introduction into why we were looking at tea. So I don't know about you, but when I'm feeling sick, the first thing I reach for is a cup of green tea with honey. And so we reach for it because we know that it has health benefits, but I don't know if you realize that depending on what season the tea is harvested in, you're going to have a varying composition of those health benefit compounds and also the components that are responsible for quality. So spring tea is the high quality tea. If you do loose leaf tea, a lot of the tea that is sold from spring harvest tends to be more expensive because it is high quality. And a lot of the tea bag tea is blended from multiple seasons because that's how companies like Lipton and Bigelow use their products. So they blend many seasons together so it's a consistent product and they don't lose consumers. So there are two different aspects to tea, what we call the non-volatile metabolites. Those are the catechins. Those are the antioxidant compounds that people really associate with green tea. And then there's the volatile metabolites. So when you put a cup of tea in front of you and you don't taste it and you just smell it and you get all of those earthy and floral notes, those are the aroma compounds. And so that's specifically what I focused on in Professor Al Rabat's chemistry lab. And so I said there were many other aspects. So we were looking at the chemistry, but we had the nutrition school looking at how different harvest seasons affected consumer preference for a product and also farming practices. So organic farming versus non-organic farming, pesticides, and so forth. And then we had two anthropologists, cultural anthropologists as well, that were looking into farmer livelihoods. So it's not just a cup of tea when you put it in front of you. There's so many different things that go into the tea product itself. And most of the time you're just like, I like this, or oh, I don't like this. And you don't really think about a lot of what's going on. So I've more or less become an expert in tea over the last couple of years. I never really thought that would happen, but it has. So obviously the key to understanding, all of these benefits, whether it be health or quality, sensory, is being able to obtain a full profile of the metabolites that are in the tea. So being able to identify and detect these compounds from a cup of tea. So just to kind of go over maybe some of the metadata that's involved for this project, there is, the sample information is obviously key because, like I said, we have 2 different seasons that we're looking at, and this is a 4-year grant. 4-year? I think it was 4-year, yeah, 4-year grant. Thankfully, she's sitting here. So we have quite a bit of data coming in. We've collected tea starting in 2012, and we've collected it every year since. And so we have to look at location. So we collect the tea from the Yunnan province in China to start in 2012. The elevation, because not only is spring tea higher quality, but tea that's grown higher up on a mountain is higher quality. And then the season, like I said, so there's a spring season and a monsoon season. So the spring season is hot and dry, and the monsoon season is, as you can imagine, wet and cold. And so moving on from the sample information, then it's, well, how do we get the chemicals out of the tea plant? So we have several different extraction techniques that we use, so we have to keep track of those, because depending on which extraction technique you use, it's going to affect the chemicals that you're actually extracting out of the plant. And then once you have the extract prepared, then you have to decide, okay, well, how am I going to analyze this? What specific components am I looking for? Because depending on that information, you could use one of many instruments. And then so there's also the method file. More into the science part of stuff, you need to know how fast you're going to increase the temperature of your oven to make sure the components are separating enough so that you can identify them. There's different columns that you can use, and the columns are chosen to separate out components. And the best, I'll get into that in the next slide actually. And then obviously the funding source. Compliance, you need to know what funding source you're using, what the grant number is. I don't know the grant number, so that's actually just goes to show you that I can write it in my publication at the end, but when I'm writing notes in my paper notebook, I don't write anything down, I just write, I prepared tea. So these are all things that should be tracked through an experiment, but the reality is sometimes they're not. And if you were to look at my lab notebook, it is actually quite shameful. So just to show you kind of how we analyze the tea metabolites. So first what we need to do is we separate the compounds based on differences in molecular properties. And the best way I can explain this is, imagine you have a cross-country team running down the beach, and there's 5 of them. And a column is chosen because based on different properties, the compounds will either move faster or slower down the column. So if you imagine a cross-country team running down the beach on a hot day, every once in a while one will jump in the water and then one will come back in. And essentially that's what's happening in a column. You have a mobile phase that's flowing everything through the column, and at some point a column, one of the molecules will be like, oh, you know, this stationary phase looks interesting. I'm going to go hang out in there for a little bit. And then that's how, as compounds move down the column, they become separated. And then you have the identification, which is mass spectrometry. And so that is just the detector, which happens to be on the end of the gas chromatographer. And it essentially looks at the compounds and identifies them based on their mass and their structure. That's the depth of science that I will go into this evening. So just to show you, natural products are complex, as you can imagine. So 1 cup of tea yields a chromatogram, or a total ion current chromatogram, like this. And so you can see that each of these peaks, if it was clean, would represent a single compound. But you can see here that these peaks don't actually go down to the baseline. So all of this unresolved area here just means there's hundreds of compounds just coalescing. Essentially, they're coming out on top of each other. So this is just goes to show you, this is what we call a one-dimensional separation. And the way for us to be able to get out all of the information about the chemical components within the sample is that we actually have to do a 2-dimensional separation. Essentially, that just means you have one column and then you have another column that have different properties that act differently. It's almost like one of those shapes things that you had as a kid that you could only put the stars in the star shape, and so that's how it separates it out. You just have multiple dimensions. And so just to show you how many data files it takes, this is one dimension. In order to fully profile a cup of tea, if you will, it takes 30 data files. And so these are really small, you can't really tell, but essentially what happens is we take 1 minute, what are known as heart cuts or sample portions from the first column, and then fully separate them out onto a second column. And so you have to do that for the entire length of the first run if you really want to get out all of the information. Yeah?
Can you go back a little bit and explain what a column is?
Yeah.
I think
So what you have here is, this is what we call the carrier gas. So that's your mobile phase. So that's what pushes everything through the column, which is here. And essentially, all of your compounds start out at the head of said column. It's literally just it's a capillary tubing that has an extremely small diameter. It's like 0.25 microns. And it's just a coil within a heated oven. And as the temperature increases, you could see that the compounds either go into the stationary phase or keep going, depending on how they like it.
And so they move down the column?
Mm-hmm.
Okay.
Yep.
And they're all together? Okay.
Yep, so they start out all together, and then as the temperature increases and the carrier gas pushes them through, they begin to separate out. And so when they separate out, they essentially have a spike come off at the detector, and that's how you know a compound came out. And I should say this is for one tea sample from one season from 1 year. So keep that in mind. And then just to show you, so my boss always says that before we can graduate, we need to show him exactly where everything is. All of our data that we use for publications, all of our data that we ran but didn't use, every single spreadsheet, Word document, anything that was involved in our research project, he has to be able to find. And so I just want to show you exactly what our lab currently looks like. So I should say, so these are 2 local drives on our instrument computers, but we also have what we call our research storage drive. And so each of us has a folder within the research storage drive, and none of them look the same. So if he goes in there, this is why he says, before you leave, you need to sit down in my office and show me exactly where everything is. So just to show you about maybe our not so best practices of data management. So if you look at this, this is one instrument and this is the other. I'm sure you can pick out many mistakes. Number one, no one has chosen a consistent folder naming structure. Christian decided that on this instrument he was going to be called Christian, but over here he wanted to use his last name and the years. Okay, so that's mistake number 1. Number 2, this is a raw data file. Don't know who it belongs to. These are now project folders. Now again, underneath it might say who ran them, but you don't know. Then we have these 2 over here. I don't know who ML or PMA is. I know who PMA is because he also defended my year, and that's Patrick. But ML, it actually took me a while to figure out who that was because she left my first year. I figured it out finally. And then, I don't know if you noticed this, but Christian was not consistent in his naming over here. So one was capitalized, one was not. So this just goes to show you that despite you thinking, everyone has their own way of doing things at the moment. And as long as you can find it, that's great. But after you graduate, how is anyone going to reuse that data? How is anyone going to find it to begin with? Or just know exactly, like these, okay, you can tell this is coal tar, but that doesn't really tell you much else. So this was before we started the research data management project. And I laugh at it. Al would not laugh because, again, this is why he makes us sit with him before. So just to show you, so as I said, I am that tiny piece up there. I started the project late. I had other projects for my dissertation. So I am that small piece of the puzzle up there. So I did gas chromatography in 2012 on spring and monsoon. And so I had one elevation. And now these 2, 2013 and 2014, are done by the student underneath me, who's Nicole. And so she had 2 locations, 2 elevations, and 2 seasons for 2013. Then 2014, got even bigger with 3 different locations in China. So as you can imagine, there are 60 data files for each season, which equals 660 raw data files. And that's not including any of the spreadsheets, the charts, the pictures, or method files. Because within our group, we actually have an in-house software that we do all of our data analysis in. So we have raw data, which gets duplicately stored, if you will, and I think I just made up that word, but you store it on the instrument computer, you transfer it to the network drive, which is, so you have 2 raw data files that are exactly the same. And then that raw data gets put into data analysis software, and then you have that as your final process data, if you will. And so there's only 1 copy of that. But then you have all of the spreadsheets and your charts and your graphs, and as I've already mentioned, our research storage drive. Nicole, thankfully, is very similar to me because I taught her, so she is consistent with me. But anyone else on the project is, and this is just our lab. Now, don't mind you have the biology department, the nutrition department, and the cultural anthropologist. So this is why Regina had to write our data management plan, because as you can tell, how do we store and retrieve all this data safely and easily so when the NSF asks, hey, do you have this data that you used? If I'm not here and Nicole's not here, can someone go in and find this data? I mean, it's a really big problem. And so this is where I end on our poor practices, and I transition into the research data management project. And Al did let me graduate, but I'm also still there, so I have to sit down with him and actually go through all of this again. So I'm sure you guys know most of this, but what was our institutional motivation for the Research Data Management Systems project? So faculty utilize an ad hoc data management system that rely on students and research associates to store and manage their own group's data. And this is why I was saying sometimes it's really difficult to get this information from the PI because they don't actually know where it is. So the students and the researchers that are collecting the data, they know where it is, but sometimes if the PI doesn't have a really good handle on things, he or she may or may not know where that data is. So sometimes the graduate students are the best people to ask for that. And so obviously, the research data management system has to ensure compliance with the federal requirements, and that basically said any project over $100 million, or sorry, any federal agency with over $100 million in annual conduct of research and development has to develop a plan to support the increased public access to this, the results of research funded by the government. So again, with our data, we were funded by the National Science Foundation, so anything that's published, we need to be able to provide that data to the public if they ask for it, because the taxpayers are allowed to have access to that data. And then obviously, as you can imagine, as more and more data is generated, students and researchers have different storage methods, and students and researchers leave the institution, that it's becoming harder to comply with the federal government mandates, and it's putting the university at risk because it's not just the PI's problem, it's also the university's problem at that point. So as a consequence, this started before my time in 2012 and 2013, and actually Regina was part of that initial project at Tufts. And so it was between the central IT department, the chemistry department, which is how I kind of made my way into it. My PI, Al Rabat, was a huge voice in wanting data management plans or a data management system. As you can tell, there's a lot of data coming out for the NSF grant. It was also, we have a large team of librarians that help with the research data management plans, and then research administration as well. And so it says 2013, it was more of a 2012 and 2013. So that's kind of the institutional point of view, but then you have a faculty point of view, and I pulled this out, one of my colleagues found it, and it's actually a very good information because so he had 2 principles for organizing his projects. And the first one, you don't have to read all of it, is someone unfamiliar with your project should be able to look at your computer files and understand in detail what you did and why. And then he goes on to say, most commonly, however, that someone is you. As you can imagine, I started working on this tea project 2 years ago, and sometimes I open my folders and I'm like, what was I trying to say here? Like, where was I going with this thought? And I mean, it's the reality. Sometimes if you don't look at something for 6 months, you just really don't remember it. So that's huge. And then his second principle is everything you do, you will probably have to do over again, meaning that the experiment you did last week or even the set of experiments you've been working on over the past month, you'll probably need to redo. But if you've organized and documented your work clearly, then it'll be so much easier to do. Whereas if you have to go through and you say like, oh, how did I do that? You know, it might take you a couple more months. Okay, so what were the goals for this Research Data Management System project, which from now on I'm just going to call RDMS. So it was to implement, manage, and support a university-wide RDMS for the research community at large. So we're not just talking about science labs, we're also talking about anthropology, psychology, humanities. Any research group at Tufts, if they're funded by a federal grant, they need to comply. So it's not just about science, and that's been one of the kind of eye-opening things for me at least, is thinking, oh, science, they're the only ones with data. Obviously that's not right. So many people are working with data. So we had to find some sort of software platform that would work for everyone. And so obviously it's to allow people to easily, quickly, and securely store, manage, and retrieve all of their data. And so the first thing is that it's going to put Tufts in compliance with federal requirements. It will increase the ability to share data with the public, search all experiments, create a historical record of data through versioning, and most importantly, save you time. So as I mentioned, this started in 2012 and 2013, and there's been 3 main phases at Tufts. So when Regina was involved in the 2012, 2013, and 2014, we were in what we called the exploratory phase. And so here we were doing a market assessment. As you can imagine, as Regina said, electronic lab notebooks are starting to really become more popular with universities. And it's not just electronic lab notebooks. They have laboratory information management systems. There's a number of data management systems. So there's a huge market for this. So first was to do a market assessment. And so they looked at 30 different software platforms and surveyed Tufts research community to kind of understand what their current data management practices were. In 2014, they did a selection phase, and they actually chose 2 software platforms to pilot at the university. And through this, they learned how about what sort of training would need to be done, the support capabilities of the team, and then they got feedback from the university. And then in 2015, we did an implementation phase where we again had pilot labs, and we're going to do a production rollout. So as I said, this is actually, I meant to take that slide out. So as I said, they did a survey, and I would like to say, as you can see, but you really cannot because it's very tiny. There were a number of different features that the university at large was questioned on, and there was 197 responses. If you can imagine, that's actually huge. I mean, usually you send out a survey, and how many responses do you hear back? So to hear back from almost 200 faculty members at Tufts was really great. And this is actually what enabled us to get such positive feedback and choose the proper software platform. So you have the number of respondents up top. Along the bottom are the different features. Green means useful, yellow is neutral, red is an impediment, and gray just means they left blank. Just to read across a couple of these, the top 5 were the ability to search within saved documents, sharing documents with groups of users, reanalyzing, not only viewing the data, web-based platform, and login-based authentication. So login-based authentication is just using what we call our Tufts UTLN and password. Makes it easy. You only have to remember 1 username and 1 password, which is surprisingly really difficult still for some faculty members. So those were the top 5 most useful, and then the top 5 ranked were the web-based platform, the electronic lab notebook, integration with Microsoft Office, and login-based authentication and sharing documents again.
I was looking at some of the ones that were more high on the impediments.
Yes.
And it looks like one of them is making data available to the public.
Yes.
Which seems like an issue
Oh,
because
well.
that was one of the motivations for the project, right?
Yes, but what you'll find is that PIs are very unwilling to share unless they have to. So any data that goes into a publication must be provided, the access must be provided to the public. But it's not any processed data, so that could just be raw data. So you could put a folder of chromatograms like I showed you on the screen, and I'm sure you guys had no idea what that meant, and that's what you have to do, and that's it. And so it's actually, the ability to share needs to be there, but people don't really want to do it. People are they want to keep their own data because there's always intellectual property. I mean, it might come up, like if you share, then someone else might steal your idea. So yes, it does seem hypocritical, but they want the ability to do it, but they might not.
Sharing and reuse is probably two of the most stickiest points of OSTP's mandates. That's the hardest thing. And researchers, we come from a long tradition of researchers that this is how research is done. And then you publish. And you provide the data in your article. And if you want the raw data, then you email or you call. This is completely different now. And the reason why is because it's funded by the government.
Right.
Now, you get into all sorts of issues in terms of proprietary data, human subjects data, that type of thing.
Yeah.
And then there's a lot going on. And we will be talking about that later on too.
And that came up again in the implementation phase. And it was always like, well, if I put my data into this system, who's going to be able to see it? And, is Dr. XYZ going to be able to see it, or is it just going to be my lab? So it is still a big concern. And that's one of the biggest challenges, honestly, is getting people to let go and realize that, they have to share it, whether or not they want to. So I'm glad you pointed that out because I didn't catch that. Real quick, I'm sure you guys have seen the data life cycle, and I know people are moving away from it. There's many different versions. I just wanted to point out just a couple of things to think about in terms of when I'm going through my research, like what I'm thinking about at this time. So creating data, this is kind of what I was going through with the sample login. So you have your locations, your season, all that stuff. You collect your raw data. With that data, you have obviously experimental information, you have observations, you have measurements, and you have to be able to capture your metadata, which is huge because if you don't capture that when you create it, odds are you're not going to capture it. Then you have your processing of your data. Like I was saying, we do all ours through an in-house software. So that's interpreting your data, creating tables, charts to make your data readable. That's in a format that is, sorry, I jumped ahead. Then you have to review your data with your PI because obviously you can't publish anything if it doesn't go through he or she first. You have to pass along that data to your collaborators because if it's on the grant, their names obviously have to go on the paper as well. So they have to be told, or shown the data at least to make sure that they agree with the data and that their names aren't just going to go onto a paper. And then you have your preparation of your manuscript. Preserving data. So again, migrating a data to a format that's going to be readable. So one of the softwares that I'm going to show you converts everything to a PDF because they think that 20 years from now that's going to be readable. Whether Word or anything else is going to be around. So they chose PDF, and let's hope they're right. So obviously I was talking about kind of different where we store our data. So you have to are there duplicate copies? Are you storing on your local drive, on a network drive that's hosted at Tufts? Are you going into a research or a data repository? And again, creating metadata and documentation. So at this point, you need to, make notes to yourself and to future researchers. Anyone that's going to use your data, you need to explain fully in detail what this data is, what the results were. And then obviously, we've seen file, folder, organizational schemes are huge. And then sharing data. So share with your collaborators. You have to share with the public. You have to promote your data and then control your access. So it has to be through a secure method and obviously a DOI. I'll get back to that in a second. Reusing data. So again, you have students that are constantly coming into the graduate school. They're entering the department, and they might have chosen to come to Tufts or any other college because they saw this project you worked on and they want to take it further. But if they can't find the data, then how are they going to do that? So it's like crazy to think that what you're doing now and how you're documenting your data might affect someone 10 years down the road when you just want to finish your PhD and move on to the next step. So based on the pilot, we were hoping that one would be good, but actually what we found out is that because we were looking at such a broad research community, we ended up just going with both of them. And so it was Agilent OpenLAB, and this is a more comprehensive solution, which has an electronic lab notebook and the enterprise content manager, which Regina was just referencing with the tagging and searching and associating files. And then Lab Archives is a cloud-based electronic lab notebook. Okay, so first I'm going to talk about Lab Archives because it's more of, I hesitate to say simple solution, but it's just an electronic lab notebook. And even saying just an electronic lab notebook might get me into trouble. So it runs on all platforms, Windows, Mac, Linux, iPad, and Android devices. So they have a mobile application that you can pull up on your phone or your iPad or any tablet if you're in the lab or in the field, and you can record data into it. Also with that, if you know you're going to be offline out in the field in the middle of nowhere collecting tea, you can download an offline version of your notebook and still record data. So you could write out your experiments before you leave and then take down your observations and measurements in the field. So this particularly is good for sharing with secure global reach across labs, institutes, and universities. So you're actually able to share your data not with people that are have access to your notebook, but also with people outside of the institution. You have the ability to grant access to a guest. They have either read or edit access, depending on which permissions you grant them, for 60 days. So it's really easy if you have collaborators at Montana State to say, hey, check out this page in my notebook, what do you think? And they can get in. They obviously have to sign up for a Lab Archives account, but they can still access your data. You can utilize a DOI, so you can create a DOI directly from one of your notebooks. So there's actually a Create DOI button. And this was where I said it got a little bit tricky, because there's different, there's global administration where you can actually turn off public sharing. And this is something that the university has struggled with, because obviously people want to be able to share their data, but do people really understand what a DOI is? If they are like, oh yeah, this is great, I can send this to my friend, but guess what, then it's out there and you can't take that back. So we've kind of struggled with where we should be lenient with stuff and where we should actually be more secure about this. So that's why I laughed before.
I'm sorry,
Yep.
does everybody know what a DOI is?
Oh, yeah,
Okay.
sorry,
I just wanted
yeah,
to make sure I didn't be surprised.
yeah.
I have a question
Mhm.
actually about that. So you get a DOI for your whole notebook or for
Page.
like a folder, a page?
You could, I want to say I think you could do a page. You can definitely do a folder. I'm not entirely sure if you can share a whole notebook through a DOI, but I know you can definitely do pages.
And what would constitute a page? Like a page of data?
Yeah, and so I'll kind of show you into it a little bit. Essentially what you have is you have a folder structure on the left-hand side of your window, and within that it literally says add a page, but you can, within that page, let's say that's one experiment, but if you had like 10 trials to that experiment, you don't create a new page every time. You kind of just work down like consecutively on that page. So you can imagine one page would be maybe a project or a task within a project.
And you can open a whole notebook or a folder to somebody. You can give them access to that. It would not necessarily be a DOI.
Right.
But you
Yep.
can give somebody access for a period
Yep.
of time to.
For a period of time?
Yep.
You can
Yeah.
put, say from here to here, or you could open it up for the whole time. You can do whatever you want.
Yeah, it's really great. I mean, it's so easy to add people and remove people from a notebook, from a page. I mean, there's some crazy stuff you can do with permissions within there. So there's a full audit trail. So obviously, with a paper notebook, if you're seriously funded by, say, like the National Institute of Health or NSF, you're not allowed to rip a page out of your notebook because there's numbers on it and you have to sign it. So the same thing with an electronic lab notebook. You cannot delete anything. They have what they call a deleted items folder. So everything you delete goes into there and it just gets it out of your way, but it never actually gets deleted. And within each page, there's a versioning thing. So you could click it and it literally shows you everything that you've done to that page. And it allows you to revert back to it. But it doesn't delete anything that happened after that. It just shows you that up on top, like you reverted back to version 28. There's an activity feed. So if you do a notebook per lab, you can sign into the activity feed and see exactly who's doing what. So that's great for a PI. If he wants to sign in on a Friday and see what people have done all week, he can. And then they have what they call a folder monitor. And so this allows you to connect anywhere to a folder on your computer or a research storage drive, and it automatically sweeps data into the system, so you don't have to do it yourself. So you can imagine if you were, a biologist that was studying plants and you had like 500 images that you needed swept in, instead of manually dragging and dropping them, you could just, every time you added one, you set a time, say folder monitor, clear that or sweep that folder every 2 hours or something like that, and it would do that. And so with this, you actually are allowed to choose how you organize your notebook. Sorry, it's a little bit blurry. What they consider a best practice at lab archives is that you have one notebook per lab. It's just, they think, easier for the PI to manage. So you have your one notebook per lab, and then you can create a folder structure based on whether each user has their folder, whether there's folders for projects or grants, and then within those, each student has a folder. Or I don't know why you would ever do this. It mainly would stick between these three. But an individual at Tufts can actually say, listen, I have my lab folder, but I also want my own notebook. I'm going to create my own notebook because I want to be able to have kind of like a sandbox where I can play in it and then push, meaningful data or, otherwise up to here. Or you can just use it for your classes in grad school. If you want to keep track of everything, you could have your own notebook. That's outside of research data management, but yep.
So you can push to if you have your individual one, you did sandbox, it has all the versions, all the things that you've done, then you can push it to the lab?
You can share it with yourself within the other notebook.
Okay,
so you can say.
Go into
No, so when you sign into Lab Archives, it's not so you have kind of a pick list of all of your notebooks, so you can't really, unless you were if you can't really have two notebooks open at the same time, but you have all access to all of your notebooks and you could share it. It's just like a right-click share option, or you can copy and then paste it into your other notebook.
In a couple of weeks when we have the vendor talking about electronic lab notebooks in general and then lab archives in particular, I will ask him to do a demonstration.
Yes.
That would be awesome.
Yeah, and
probably answer my question.
yeah, no, yeah, and Lab Archives has been superb. They are very easy to work with. It's a very small company out in California, and anytime you ask them a question, they respond immediately. I think the 3-hour difference also helps, because if you ask them a question at 5 o'clock, it's only 2 o'clock their time, and I'm like, yes, I don't have to wait till tomorrow. So yeah, this is just shows you kind of the organization schemes you can use. Now, there has been some sort of negative feedback on this, and it's that when you open it, I'll show you. I don't know if you could read this, but this is kind of what the folders populate as when you first create a notebook. But as you can imagine, someone that hasn't done research data management, if they open up their notebook and see this, they're like, how am I going to organize this and to what makes the most sense for me now and in 10 years? So that's kind of been a little bit of a struggle, is just helping people to realize how they should implement the workflow of their lab into the electronic lab notebook. As you can see, they have protocols, standard operating procedures, material safety data sheets, templates. They have a bunch of stuff. And again, you could rename these, remove these folders, and there's the deleted items folder. Yep.
Amanda, would you see this as a place where librarians would be, could be a part of this?
Mm-hmm.
In terms of not only educating about best somewhere like this
Mhm.
and you're overwhelmed.
Yep.
Just being able to have that support and
Yep.
organization.
Definitely. I mean, they like PIs are looking for any and all help they can get at this point because it's so new to the university. I mean, the Tufts University Library website is really great. They push you to so many different websites, you know, with information on data management. So yeah, definitely. And especially because they're the ones that usually have the most experience working with faculty. Because they help to write the data management plan. So they understand data. They, you know how they're going to organize it. So certainly, I do. Yep.
Yeah, I just wanted to add to that I work for a digital asset management software
Mhm.
company, and we work mostly with marketing departments of like enterprise
Yep.
clients. But it's interesting, the same sort of like user education that has to take place, and sort of the consulting, and we have like 3 librarians.
Yep.
You know, that identify as librarians on the team,
Mhm.
but it's not a library. So it's very interesting,
Yeah.
like, what takes place,
Yep.
client facing, to try to get
Yep.
people to do this sort of stuff,
Right.
and to be open to
Mhm.
doing certain things that
Yep.
we kind of know are best practice, but they might be uncomfortable with. But in
Right.
the end, it does matter and it does help. It's
Yeah.
really interesting.
And consulting is a huge part of this project. And we've struggled with finding what we refer to as our service owner. So I was a temporary position. I just started a full-time position at Tufts for a postdoc September 1st. So I'm winding down my hours. Patrick was, who worked on the project before me, was the same way. Now he's moved on to doing his postdoc. So we don't really have anyone that is the true owner of the project. So I've been doing more or less like the consulting and everything like that. So we put out an job description out, and actually we've had at least 5 librarians apply for the position, which is great because they have the soft skills. Like I said, they're used to dealing with faculty. They have the consulting skills. They know how to ask the right questions. So yeah, there's so many different aspects to this project, which is why our team is so big. We have 5 or 6 librarians. We have the central IT. We have the technology and infrastructure people. We have, like I said, Al, who is the faculty voice more or less within the community. So yeah, it's huge. There's a lot of different aspects. So, yeah, so just to, show you what you can do here. This is, like I said, it's more of, it is an electronic notebook. It's literally taking your paper notebook and making it electronic. You can do rich text entries, so anything you would do in Word. You can organize all of your lab documents. So there's a little bit of caveat, so you can attach files up to 250 megabytes within the notebook. Anything bigger than that, you have to create a link, which is a little bit tricky because remember, you create the link to somewhere on your computer, but if you move that, this has no idea of knowing that. So when you go to click it, it's like, all right, well, where did that go? So you have to be a little bit careful about that, which is why the folder monitor feature, which they're launching now, it's in beta version, is so good because you can say, I just want you to look at this folder, and then that will kind of monitor it and hopefully not break links. And then this is also really cool as well because as you said, or if you remember back in the interview, people wanted to be able to work with Microsoft Office documents. So this actually has a plugin that you can work with an Office document in Office and then save it to your lab archives lab notebook. It actually becomes an option if you download that plugin. So, yep.
Does it stay a doc
Mhm.
code file?
Yes. Yep, it stays in its native file format, so you can open it up back and forth. And then we go to Agilent OpenLAB. And actually, let me take a step back. So lab archives, as you'll see when Kip, is that his name? Yeah, when he comes on site, they have been in higher education for quite some time now. They have Cornell, University of Wisconsin-Madison. They have several deals going with local community colleges around here. Not community colleges, but they have community colleges as well. So they have been in academia for a long time. So their support's great. They have a great knowledge base. But there are some things that it falls short with. And so it's like I said, it's a paper notebook that's been turned into electronic. But you miss out on a lot of the other things. You can share data well, you can collaborate well, but there's not a lot of tagging. You can add tags and to different pages, but it's not a comprehensive solution. It's just an electronic lab notebook. And so now we go to Agilent OpenLAB. And so this is more of a comprehensive solution. You still have the electronic lab notebook, though it's very different. Lab Archives is more of a user-intuitive, and I should say for training purposes, Lab Archives does a free webinar every week for the community. Agilent, we are one of the first institutions, higher education, that they are implementing the software in at a university-wide implementation. They have a couple of clients that are either departments or single labs. So when you first look at this software, it's not as user-friendly as Lab Archives. Lab Archives is bright and it looks modern, and so people were a little scared when they saw Agilent, because again, they're taking on already trying to organize their data, and then they have to work with a product that might not be so user-friendly out of the box. So you have the ELN, and then we have what we call the ECM, or the Enterprise Content Manager. And this manages large data sets. You can add files manually. You can sweep them from an instrument computer or any computer you'd like. Secure files over the entire life cycle of the data. They actually have a retention policy for data. So if you know, and I'm going to get this wrong, NSF, maybe 7 years you have to hold on to data after publication.
And I also think it depends on the
Type,
business
yeah.
and the type of grants.
Right.
But 7.
Right. We'll say 7 for now. So like we already discussed, that sometimes faculty want to share the data for as long as they have to, and then they want to pull it. So you can set retention policies to say, starting from now, 7 years from now, I want this deleted, or at least removed from the public folder, if you will. What you'll notice here is that you can use Windows and Mac for the ELN. Windows, and then you have to use what we call a web client, which is just a way for Mac users to use the ECM, because it was built for Windows. And this was first implemented, I should say this, these products are really for like the big pharmaceutical companies and more of the industrial labs, which is why they were not ready for what we had to offer them at Tufts. So as you can tell, this looks very different from the Lab Archives. And I blurred this out just because those were the names of the pilot labs. But what you have here, and I will try and go over it in detail, is on the left here, this is what the repository tree. And you can see that you have templates, forms, and fields. And so this is not a template either. This is an experiment. So right off the bat, you have 4 terms that confuse people. And they're like, wait, what? How do I don't understand. What is a template? What is a form? What is a field? So a template is essentially what it sounds like. It's something that you're going to reuse over and over again. And so you use templates to create an experiment, which is this here. And then everything here that you see that has a gray background is what we call a form. And again, forms are used over and over again. And I look at your faces, and I did not see these when I was talking about Lab Archives. So as you can imagine, this was a little bit of a struggle, because out of the box, I mean, Regina knows, it was really hard to use. There was a lot of customization that needed to be done. And we started the pilot lab in March. And we're still working with them. And from then to now has been a world of difference. But it's been a very long journey with this. Just because as much as we were learning, Agilent was learning as well. And so it was actually, it was a good relationship. I mean, we're trying to help them move into academic institutions, and they're trying to help us understand what's going on here. So what this experiment looks like, this could be, it's called the individual analysis template. And so this is supposed to be used for an everyday experiment. You know, you go into a lab, or you go into, your research office, and you're like, okay, I'm going to sit down and I'm going to do this task. This is what this template's for. And you can see there's a ton of metadata that we've incorporated. So like I said, you need to know what instrument you're using. Sorry, I'm moving in front of the thing. So you need to know what instrument, your project focus, that's also metadata, because you can search on that. And then the funding source, which as you can tell, B is not a funding source, we haven't fully populated that list yet. And then you can see we have the title, we have the objective, we have keywords. So anytime you see a pick list, that's a way for us to ensure that people are not going to misspell things, because you can search on any word you want, but if you misspell it, how are you going to know you've misspelled it? So that's what these pick lists essentially are. And it's not just so simple as creating a pick list, because as you can imagine, instrument name isn't just going to be a field used for one lab. Many labs are going to use that. Many labs have instruments. So what we had to do, and this is now more on the tech side, is we have essentially what they call a web service where you can type in all this information, and when you're granted access to a lab within the notebook, it actually calls upon that and says, okay, Amanda's in the robot lab. These are the things she could pick from. So it's actually really great because you can reuse these. So for we've used all three of those in all of the pilot labs. So you start to see a pattern and you realize, wow, we didn't really think most people were going to fit to these templates. You know, we're like, every lab's going to be different. But you start to see a little bit of some commonality between the labs. Just to go quickly over these, you can see these are different chapters. So you have the header. This is where all of your sample information is, you know, why you're doing the experiment. You go on to experimental methods, and that's where kind of the forms come into play. So any standard protocols you do every day, you type into a form, it's saved, and you can just drag and drop it. Data acquisition and data analysis. This is actually really cool, and Agilent has been very helpful in creating what we've called widgets. Lab Archives has widgets as well, and they're right out of the box. This has been more of us creating the widgets. And essentially, a widget is a form, and what they have done is created a widget to link files from the ECM into the notebook. So what you do is it opens up like a table, and you click on a button, it sends you out to the ECM, you select the data files that you want, you hit OK, and then all of a sudden it populates on your ELN experiment page. So now you always know you're not going to break that link. You know where that data lies. That data cannot be deleted because we've turned off you may not delete data from the ECM. So now people know that at least once something goes into the ECM, it's not going to be deleted. It's not going to be lost. And that's one way that this is kind of beneficial for Agilent, because in Lab Archives, where if the data is over 250 megabytes, you can't link it. Or sorry, you cannot drop it into the folder, you have to link it. Now with Agilent, you have a 10 megabyte file because it's a paper notebook. You can imagine you're not going to be able to take data off of the computer and like tape a floppy disk to your electronic or to your paper notebook. And yes, I said floppy disk. So with this, like, the whole point is not to put raw data into your notebook. It's for process data, it's for the pictures, it's for the explanations. And so that's why they've limited it to 10 megabytes. So that's what these are. And then outcome is kind of free text. You say, hey, did this experiment work? Oh, it didn't work. What went wrong? Do I need to redesign it? Do I just need to redo it because I dropped my beaker and I don't have any stuff left? So, I mean, it's really good, and it's way more structured than Lab Archives. So we've had a lot of positive feedback on that. And then this is really cool too. So this is an individual task. So you can imagine this is one extract for me in the T project. And then we've created another template, which is a project overview. And I didn't show the most important part of this, which is the task list. But essentially what it is that information button up top. When you pull that down, it has this experiment number, the AS-ALK-00028. And that just means arts and sciences, my initials, and then the page number in my notebook. But what it does is it allows you the ability to copy that project overview, which is, this is the 2012 NSFT data project. And then you can go back here and paste that here and say, okay, now I know these two experiments are linked forever. Unless, of course, you delete them, which you shouldn't. But if you don't delete it, now anytime you want to look at projects that this experiment's linked to, all you do is you hit open and it opens that experiment up for you. So it's really good, actually. It's been great. And that's why so many people have adopted these two templates, because it's a way for people to link their experiments to the overall project and they don't lose sight of it. And then with this template, which I know looks exactly the same, the task list there, you actually get to do the same thing for the individual experiments. So you just link the page numbers and it creates a link between them. What was I going to say? Yes?
Is this something we'll also be able to see demoed, or is this, they're not totally there yet? Or?
No. Yeah.
It's sounds like when you have to tug it, muck it.
Yeah.
They might-
I mean, they've launched a couple of other universities, but like I said, it's just mainly departments or a single lab. So.
The reading about ELNs will be very general.
Mm-hmm.
And unfortunately, I don't know the Agilent people anymore. I know the lab archives person. So you're going to get a little bit more from their point of view. But hopefully the reading will give you a good overview about in general.
So it sounds like right now there's a ton of back and forth when it comes to setting up like what metadata should be in the system. So is there someone at Tufts who eventually will be like responsible for this, or is it going to go back and forth with this?
That's the service owner. Yeah, because right now and this is one of the biggest challenges with having two is, you have to understand where the metadata is incorporated within lab archives and then within Agilent, and then you have to manage it.
And those two correspond, right? Because they go back and forth.
No, between lab archives and Agilent.
Yeah, I thought you said something about being able to transfer data back and forth. Is that
Yeah, so that's within Agilent, so within the ELN and the ECM.
okay, but not.
Yeah, right. Yep. So yeah, it's been kind of a challenge. There's a lot, and I mean, we chose the two products because it was the best situation for the researchers. We realized that one of them wasn't going to be great for everyone, but both would suffice, and it would help everyone. So it's been a lot of work, as you can imagine, because this required a lot of customization. When we first opened the software, it was completely blank. So all of this folder structure, there was nothing at all. So we had to build all of this. And you can see like any of these guys here that have like underscores, those are really just for administrators, because administrators can create the fields and they can create the templates. All the lab can do is create experiments off of those templates and create their own forms. So there's a lot of back end work on this for the eventual service owner, whereas with lab archives, the researchers do everything on their own. I mean, they can ask for help when they need it, but here people are limited. So with the pilot, we did like all Agilent first and then lab archives. So we certainly could not onboard two labs, one lab archives and one Agilent during the same week. There wouldn't be enough time. It takes essentially what we do right now for Agilent is we do 5 days of onboarding. So we sit down with the lab, usually it's a PI and a couple of the head or more senior graduate students or postdocs. We interview them, try and understand what data files they're working with, what the workflow of the lab is, and that's on Monday. And then all day Tuesday, we try and take that workflow and somehow make it work within the system. And then Wednesday, we go back and we show them version 1 and we say, will this work for you? And if they say, sure, it does, but tweak this. Sometimes it's like, I hate it and I can't see myself using it. Then you have to start back from scratch again. So.
That's for Agilent?
Yes, that's for
Back
Agilent.
and forth, okay, that makes
Yep, yes. So the Agilent is a 5-day onboarding period. Lab archives is 1.
So how many labs do you have?
Currently, we have 6 for Agilent, and we only have 4 for lab archives. That's one of the challenges as well. Faculty members are never around in the summer, so that's when we chose to start it, because it was going to be easiest for us, and we realized faculty's not really around. They're visiting China collecting tea or just on vacation with their families. So we wanted 6 for each of them. So we hit them for one, not for the other. So just to show you real quick what the ECM is. It looks like Windows Explorer, essentially. Not joking. So they have what they call an LCDF structure. So you have a location, which we've decided is always going to be the PI. And so that shows up as a house on the software. And so the house is the PI. And then within that house, you have a filing cabinet. And the filing cabinet could have any sort of, you could do it by user, project, grant, instrument, similar to lab archives. And then within the cabinet, you have drawers, and then you have folders. And as you can imagine, data files cannot just be dropped into a cabinet. They have to be put into a folder. So data files can only go into this folder. So you have 4 levels, which when I first saw it, I was like, oh, I have 10 files. What? How am I going to work with 4? And then I realized it's probably really smart because it actually helps you organize your data. So, and then they have, you could, if you zipped files, you can make a pseudo fifth level for storage of data files as well. But that just shows you it's actually like Windows Explorer. It's just, they get saved within their normal file format within the system. It doesn't show up like that, but they don't ever get changed. Like to your point before, you were saying, does it stay as a doc? It would still stay as a doc in here as well. It just doesn't show up like that. It shows up as an SSI zip file in the system, but if you download it, it's a doc file. It's just how it displays it to conserve space. So just real quick to show you kind of the workflow between the two of these. So first, within the ELN, you capture your experimental details. You have your samples, your protocols, and your methods. Then you have your data acquisition. The raw data gets either swept or manually added into the Enterprise Content Manager. Then you can link to the data files within the ECM. Oop, there we go. Data analysis. So using the raw data files, what I will say to here is that any file that is stored in the ECM, you should never try and pull off and analyze. You're going to become frustrated. So essentially, it's almost a duplicate copy, similar to what I was saying before. You put a copy in the raw data, or sorry, into the ECM, it doesn't get touched. You also have that file somewhere else because it takes a while to download files from the ECM. And then you have your data analysis into the ELN. You copy any charts, graphs. You can add spreadsheets directly in here. Similar to Lab Archives, if you drag and drop a spreadsheet or a Word document within the ELN, it saves a copy onto the ELN server. So it just creates a copy. Anything you then, if you open it from the ELN, it opens it up as a new, you'll see like a weird file name, but it stays the same. And any edits you make then get saved back here, but it doesn't change your local copy. And then you have post-analysis. Any process data also should get pushed back into the ECM as well, just for storage purposes. And you can do instrument data, music, pictures, anything, videos, can all be stored within the ECM. And so with each of those, obviously, there's metadata associated with them. And so this comes back to one of our pilot labs has come up with a very detailed ECM use case in which they almost want to use it as a lab brain. It's more of a LIMS, so it's a laboratory information management system, is what they're looking for. But we're trying to come up with a way for them to use the ECM like that. So they want to have like this repository of manuscripts and data. And anyways, essentially what they're able to do is within the ECM, they can associate files. All you have to do is right click and say associate file, and you can link to another one. So if you ever search on one, those all come back up. And you can also do that with tags and filter keys is what they call them. So whether it be a gene name, plant species or something like that, that's how you would do all of the tagging, would be within the ECM. Okay, so just to show you, we have 3 campuses on Tufts. We have Medford, Boston, and Grafton. So I just wanted to show you that we were actually able to capture all 3 campuses with the pilot. So Medford for Agilent, we had a chemistry, which was my lab, biology and biomedical engineering. Lab Archives was a chemistry and 2 biology. In Boston, the Human Nutrition Research Center for Aging had 2. And that was actually really cool because one of them was a core facility. So the data they generate, they don't actually care about. So they were a little tricky to get to be like, hey, you actually need to save that data. You can't just throw it away. But they actually struggled with how to get people their data because people were actually just handing thumb drives to them and saying, put my data on that. And I'm like, I would freak out and think, I'm going to lose it, spill coffee on it. So they were really excited about the ECM because they can actually share data with collaborators within the HNRC school. And then we had a neuroscience. And then on the Grafton campus, which is more of the vet school, we had an infectious disease and global health PI. So as you can tell from this, mainly science, right? But the big picture is to be able to implement this data management platforms into any lab, any research group. And that's where I struggle with this because I always say lab, but it's really not for labs, it's for research groups. So anyone, someone taking pictures, art history. We had in the pilot phase this first pilot phase, there was an art historian that was interested in using it. So we tried to, at least we hit all 3 campuses. We're going to move on to more of the social sciences and humanities, when we do the actual production rollout. And then, 5. Just math in case I couldn't do it in my head. And then just to go over some of the challenges, this is the last slide. So we were the first university to launch a university-wide research data management service with 2 software solutions. So as you can imagine, when asking for help, we got a lot of help on the lab archive side. With Agilent, there was very little help. And just in terms, thank God that we had University of Wisconsin. There was a woman named Jan Cheatham, and she did lab archives implementation, and she's been so helpful in helping us with the sign-on. So we wanted to control access to this. So we wanted to use an Active Directory and say only these people that have gone through both the library training session, which is best practices in data management, and the actual end user training. So how do I use the system? Only those users should be allowed to go into the system. Because if you let everyone in and then, a year from now they come back and be like, I don't really know what I did. Can you help me find my data? And that's, as you can imagine from the beginning, not going to be easy. So we reached out to her a bunch. And then the biggest lesson learned was to do things slowly and right the first time. And this is a direct quote from one of the pilot labs. I actually took it out of his email, and it said, I'd rather you do everything correctly and take more time so that my researchers can use the software without any hiccups. And this was with respect to Agilent OpenLAB. And so throughout this, we've struggled with the fact that we don't have the service owner yet. And we had a timeline, and it keeps getting pushed back, but we've realized that if we launch now, which is when we said we would, it would not go well. There's just too much to do. And with faculty and PI, I don't know how many of you have dealt with them, you really have one chance for a new solution, new software. If they don't understand it the first time you show it to them, they will never use it, which is bad because Tufts needs to implement this for compliance. So that's been a struggle, but we've definitely learned that. And luckily, that was Lab 1 that we learned that from. So Lab 0 was my lab, and then that was Lab 1. So we learned that lesson early on, and it was very helpful. As I've already mentioned, summer is the difficult time for faculty, which is why with Lab Archives, one of the original users ended up leaving the university, so we weren't able to use him in the pilot, and it's just hard. People are traveling, trying to do their own research, so this was, as much as it is going to help them, they just couldn't see past the implementation and trying to use it. And so that's also one of the biggest challenges is convincing faculty that this is a good idea and this will help them. So to your point, it's a consulting job. You have to go in there and you have to be ready for all questions, everything, and still be able to say, I understand your point, but this will help you because. So, and then again, just balance of customization versus out of the box for Agilent. So to what point do you tell a lab that you cannot help them anymore? Because, they will ask the world of you. And you want to help them, but you can only give them so much attention without letting everyone else flounder. So you have to be able to understand, if it's something like, for instance, a barcode generator. A lot of people use barcodes at Tufts for sample identification. So if it's a request like that and you know that down the road a lot of people are going to use it, maybe that's something you spend time on. But if it's something that it's just very specific to that lab, then you're like, all right, you know what? I understand your needs. What if we have this done for you in 3 months? We can't do it right now. And that's really hard because, again, you're trying to get them to use the software. So there's a lot of push and pull, and you don't want to lose their interest in that. So if you have any more questions, I will gladly take them. Yes?
Going forward, how do you see the group managing having 2 software platforms? Are there certain labs that you would target for one specific software?
Yeah, and that has been one of the things we've been trying to do is almost to do like a vendor selection guide. And we've pretty much said anyone that has an instrument, and it doesn't need to be a scientific instrument, you can imagine an instrument being a camera, should probably go with Agilent. But again, we're not telling people what to choose. We're simply saying, we think this would be your best fit. But yeah, so it's the instrument's big, data files that you work with. We kind of have like a navigational tree where it's like, do you use this data? And then you say yes, you kind of get hit to another one and go like that. So it's going to be tough, right? Because you don't want to push someone down the wrong road and then them realize 2 years from now, oh, maybe that wasn't the best solution. So you cannot, I cannot physically say to someone, you need to use this software, because then they'll blame you. So you have to just give them enough information about the features of each and say, based on your needs, I think this will be the best fit. Exactly. And I've practiced that line, as you can tell. You kind of get used to that. But yeah, essentially moving forward from here, when we do actually start our production rollout, what we imagine happening is that 1 month will be dedicated to Agilent OpenLAB, and then the next lab will be dedicated to lab archives, just to try and manage the work that comes out of Agilent. Because like I said, there's no way you could ever do an Agilent lab and a lab archives lab on the same week. It's just too much. Because you have to do, again, there's like the consultation meeting to say, like, what is your data? What do you do with your data? So that is the plan. It's a little scary to think about, but.
So Amanda, I have a question here. When we look at today's research lab environment, where do you see it heading, let's say in the next 5 to 10 years, and maybe even beyond?
Based on the pilot labs, there's been so much hesitation because people are stuck in their ways. So it's going to take a lot of convincing. Luckily, Al jumped right on board and saw that this was this was necessary for our lab, because, at the end of my PhD, maybe I don't have to sit down with him anymore. Maybe he just can go into my notebook and say, oh, here's all of her data. The publication's there, the data's there. So I think, within the next 5 years, lab notebooks have been around for quite some time, right? So, and we're just starting to implement them at Tufts. So 5 years from now, I think you'll have kind of maybe the early adopters of the ELN, and then I think maybe in 10 years, that seems crazy, but most people will actually be using them. There's kind of like the new, I don't know if it's like a new software or technology paradigm, and there's like a bell curve, and you have like the very early adopters, then you have, average people, and then the late people that don't really want to move away from their ways. But yeah, we've had, talking to one of the faculty members, and he was like, do you mean I have to take everything off of Box? I just figured out how to do that. And I was like, okay, we'll work with you. But yeah, it's going to be difficult. I really don't think it's going to be very quickly adopted.
That was my follow-up question in terms of everything we talk about, putting things in the cloud.
Mm-hmm.
As a researcher,
yep,
and as someone who works so closely with researchers,
mm-hmm,
how confident do you feel in terms of data security in the cloud?
Right. Yeah. It's a great question, and I don't put any of my data up there. I have, when I do my data, I have it on the research storage drive, but that's local to Tufts. I have it on my local hard drive, a thumb drive if I'm really nervous. But yeah, I still get nervous, just not even with research data, but like just my general information, like filling out an application with my social security number, I will never put up on the cloud. That's just my personal point of view. So I have a feeling with like HIPAA data and a lot of the FERPA and Department of Defense, we went to the ELN user group meeting for Agilent, and they literally built their own cloud. So they have like their own cloud at this one industry. And so they have all the security measures around it. So even them, they said that it took people a while to be comfortable with pushing it up there. So
Actually, I had another one, but please, because we have to think about one of the things when phase one of this,
mm-hmm,
I heard a lot of PIs saying, okay, so we'll do the ELN, say lab archives, but we'll also keep the paper one as well.
Oh, you have no idea.
Yeah, And of course, the problem with the paper ones is space. We have looked into, at UMass, doing a project with one of the labs of scanning their lab notebooks. Scanning isn't that great. You can do some searching. It didn't do what they wanted to do. And if they're not willing to, well, we don't know this for sure, but a lot of faculty or PIs are not willing to give up that, that print.
They don't have like a stylus sort of hybrid thing, like all these popular Galaxies. So in other words, you have your electronic whatever, but then it has a touchscreen interactivity with a stylus, and you can scribble.
You can do that with Lab Archives because they are on all platforms. Agilent only has one app, and it's for the iPad only. And it's great that they have the app, but it's more or less useless.
It doesn't win anyone over, though. It doesn't win over any traditional notebook.
Lab Archives certainly does. The ability to take out your iPad or your Galaxy tablet, and you can. You are opening your notebook with the Agilent app. You are opening up part of it. You can set timers and take pictures, and that's really it. It's not like the full notebook itself, but we've had a lot of people that have freaked out about going completely electronic. There's been a lot of people that are kind of going as hybrid adopters for now. They're going to stick with paper and electronic. Lucky for us, most of our stuff has been electronic anyways, because we do everything on the instrument, and then we have the data analysis software, and then spreadsheets. So a lot of our stuff isn't written down. So that's why we're ready to kind of push forward. Any data before this, it'll get pushed up into the ECM, the raw data, but we won't have anything in the ELN for it. But just to your point, we're not going to sit there and scan it because it's not really going to do much. But we've also had the questions of people saying, what if the internet goes out? How do I access my data? And I'm like, why didn't I think of that before? And I'm like, well, if the internet goes out, we have bigger problems. But it's not just like the actual, because the Tufts the Tufts network, if that goes out, there's literally, you cannot do anything because, that's where everything, at least for Agilent, is stored at the data center at Tufts. So, but these are things you have to think of. And it's like, what if someone opens the the networking closet and decides I've had enough and pours coffee on it? How do you, you could do the same, well, I know it's a bad example, but the same thing can be said for a laptop or a paper notebook. If you spill coffee on it, well, what do you do? Because now you can't get that back. So there's been a lot of interesting questions like that. And it's stuff that you, don't necessarily think of because it's just like, oh, the internet never goes out. But really it does. And so that's why I made it a point to note that with Lab Archives, you can download your notebook to an offline copy if you needed to. So for instance, if you knew for some reason you had a hunch that for some reason the network was going to go out or you were going to lose power, you can download the notebook and then still work off of it. Because that was one of the big concerns was, what if one of my researchers has all of the notes in the electronic lab notebook, no longer has the paper, and they come in the next morning and the internet's down? How do they know what they're supposed to do next? And I'm like, that's a good point. And so there are ways around it. At the end of each day, if you know you have an experiment that you need to finish tomorrow, you could save it as a PDF. And that's what I said. So they chose PDF as a format. You download it as a PDF, and at least you still have it. You can write it on paper, any observations, and then you'll have to go back and put it in. But it's definitely a fear. People are a little nervous to just even go to the electronic. But the same thing can happen to paper. Someone can dump coffee everywhere, or it could, if you're working in a hood with flammable material, it could go up in flames. So, yeah, exactly.
Yeah, is there a way to download the information from the Agilent software?
Yeah, so that you can, it essentially you do what they call a printer report, and it just saves it as a PDF.
Okay, that one also saves as a PDF. Yep. But then it doesn't have all the cool linking and everything that you had before.
Exactly. You could see the links, but you can't use them. So, yeah. Right. So the thought is that in 20 years, that software will still be around, is what they're hoping. Right. So that exactly, I know. And so that's another risk you're taking. So it's like, I mean, for Al, for my boss, he's a little hesitant to push everything to the ECM because he's like, well, what if down the road that's not there anymore? So, and that's become a difficulty for Lionel, who's the project steward on this, and he's the director of geospatial resources at Tufts. That's one of his concerns because he deals with all the storage. So he has the network storage, he has the RDMS storage, and he knows people are duplicating, but the other important thing is monitoring the growth of the database. So how do you handle all that extra data that's now being stored? Because it's costly. So, yeah.
So I am just curious if they have told you anything about like how the data is actually stored in the system, because clearly it's being stored somehow, and if it's like proprietary software on the back end, like, or if the data is being stored in some way that could actually be extracted for like archiving purposes.
Yeah, especially with the ECM, it's not stored in any proprietary format. It's stored in the native format. It's zipped. But like in terms of like if you put a doc file, it's a doc file. No?
I mean the metadata that you're putting in. For I'm getting the acronyms confused.
So the ELN.
Yes.
So like the instrument name and stuff like that. Yeah.
All of that information is presumably stored on their back end in some kind of data format. It wouldn't be stored on their back end in PDF because that makes no sense, So like.
Well, it's saved within the experiment itself, which is stored on the server. And so, yes.
That's what I mean is like it's stored in a data format like XML or data formats. I'm sure they're
it's like ELN, EXP or something like that. But yeah.
Technically, it's stored in a data format that could be extracted if they would let you.
And if something else can read it.
Yeah.
Yes, exactly. Yes, so it's not currently got it. It's been a long day. Right, so yes. So for instance, one of those templates, it's .eln TMPL. That is the only software that can read it. So that's why if you need to, you save it as a PDF. That is the only thing you can do. I don't think anything else can read that format.
Got it.
Because, no.
That's what I was wondering if it was proprietary or not. And so it sounds like their back end data storage format may possibly be proprietary for their system. And that's it. Okay. That's unfortunate.
Yes.
I had more questions about proprietary raw data.
Okay.
Like I know a lot of, depending on the chemical instrumentation, sometimes like you can't even take the raw data off of the instrument and the computer that you were using to process it. Like you can only export it.
Okay.
So, like I guess in long term, do you worry about like what happens if, like how are we going to store that data if we can never store the raw data in this system?
Mm-hmm.
Or you can look at like an exported form.
Right. Yeah. And we personally have not run into that issue, and I don't know of anyone else that has either. Because to your point, unless you have the software that can analyze or open the data.
Yeah.
You can't do anything with it.
Yeah. I was at the BU Chemical Instrumentation Center. They were showing us like we keep this computer from like 1998 because it's the only one that works with this machine, and like you have to keep it active. You can't even run stuff like you can't switch it out.
So for the 2D GC that I was talking about, there are two ovens. And then we have the new mass spec. So the two ovens run off of one computer that I think is XP. And then the mass spec runs off of another computer. So there's two keyboards, two mice, two monitors, and half the time I never know which one to use. So yes, it's like it's scary. We have backup computer towers, in case one goes, because we need another one, because we can't run it on anything but XP. So that's one of the other challenges. So, hopefully a couple of years down the road that isn't a problem, but you can only do as much as the instruments allow you to do. If you can't export, then you can't. Unless it's on the network, you can just push it from that folder to the ECM if you wanted to. So you just have to make.
It doesn't even let you go that far then. Yeah.
Could I go more broadly in terms of, going from instrumentation? But you have to get the money to do this. And in the research environment in our country right now, it's very difficult to be granted an NSF, an NIH, or any Department of Energy grant. How has that affected, in your experience, how has that affected research?
So,
Directly. We had a grant, the NSF grant that I've been talking about, started off as a $1 million grant. And then someone from Congress decided that he did not want to fund a project that was linked to China or climate change. And seriously. He was like, I don't think this is where the U.S. money should go to because it's not looking, And so he said, no climate change, no China, and our grant dropped from $1 million to another amount. So we lost funding because of it. And it's, depending on what your research is, it's really tough to get an NSF grant now. And so we were so excited. And then to have it taken away from you it was hard. We were kind of shielded from it, the grad students. We didn't hear the whole end of it. We saw the story come up and it got passed around, and then we never really heard anything about it again. It's tough to get funding, really tough. We lucked out, but when I first started, we had private funding from a company. We were doing research, as silly as it sounds, on gin. And so we had money coming through from that, but the NSF grant, and I was at Tufts for 6.5 years, and that was the first big grant we landed. And if you go into our front office, the girls that work there have a huge whiteboard, and it's all of the grants that people are applying for. And it's not just the PI that needs to do it. There are so many people involved in grants. As you can imagine, you have the library for data management plans, you have the research administration, and so it's not an easy task, but it's a big win when you do get one.
And monies are shrinking. There's more accountability. You need to be able to find some way to share, depending on the type of research that you have. So the environment now, I think, is fairly complex. Let's say, compared to 10 or 15 or 20 years ago. So you can understand that PIs who, let's say, are my age and older, have a difficult time with accepting these changes. You need to do an electronic lab notebook. You need to have a content management system. And you need to be able to learn how to do metadata and to do file management. Whereas beforehand, you had a lab notebook, and you could get funded for doing basic research. And there was not a political party, usually, coming in to tell a granting agency who they could or could not fund. These agencies are given monies in order to, and they oversee this. They have, policies in place. They don't do this lightly. So it's been, very difficult, and this is, just a small piece of it.
But even growing up, you saw a published study and you're like, oh, I believe everything in it. But lately there's been so many people that have come out with, they, massaged their data, it wasn't true. And so, that's also a concern too, because they're like, what if we fund a project and it turns out that this isn't real data? And there's been recently in the news, someone was working at an institution in California and switched to another one and took their data with them, and they got a lawsuit filed against them, and it's crazy. Because who owns the data now? So there's a lot of, in the years to come, there's going to be a lot of challenges. Yep.
Something that I feel like is sort of put into this, and maybe people are already familiar with, but I don't know, sometime last year I got to go to a presentation about electronic lab notebooks on a particular lab notebook, so I don't know anything. But one of the things that she was focusing on when she was talking about it was really the data management workflow that happens within a lab, and like sort of avoiding that inadvertent massaging of data by having an electronic lab notebook. And I don't remember hers. I can look it up if you're interested.
Right.
I don't know, but it sort of had this like you have to put your projection and like what your hypothesis
Right.
ahead of time,
Right.
and like sort
So
of
you can't-
put in all that information, and it has to be there, and there is versioning, so
Right.
it's always there. You can't just like be like, oh look, I did all this analysis and found this other thing, but
Right.
like I threw out all these outliers before already and all of that.
Right, but unfortunately, some of the greatest discoveries come from a mistake that's made. So, but yes, that's true. I mean, because you, for the electronic lab notebook here, you just enter in a title and your objective. So you're like, well, I hope that this is what's going to happen. So it's kind of the same, but not that extreme.